Hello everyone. Today we will be solving the problem number of islands. The question is we are given an m cross n 2D binary matrix where 1 represent land and 0 represent water. We need to return the number of islands in the matrix. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So let's see a test case. The question will make even more clear. So this is a binary matrix where 1 represent land and 0 represent water. So all these ones will represent land and these zeros will represent water. We need to return the number of islands. So an island is adjacent lands surrounded by water. So there, for this one, there is an adjacent land here. For this one, there is an adjacent land here. For this one, there is an adjacent land here. Or you can say there are two adjacent lands for this one, and for either of this, there is an adjacent land. So these four will combine together and form a island. This is our island one. Same goes for this two. If we take this one, there is an adjacent land here. These two will form an island. This is our island 2. And since there are no adjacent lands for this one, we can say that this alone will create a separate island. This is our island 3. So the answer for this question is this test case is 3. You can see in the question, yeah, it is 3. So now we need to think of an approach to solve this problem. So what comes into my mind at first seeing the problem is like we can see this grid as a graph where one will represent the nodes of the graph, and if it is adjacent, if two lands are adjacent to each other, that means those two nodes are connected. So if we represent it as a graph, this test case, so this will look like something like this. These four are, since these four are adjacent to each other, uh, these four will be connected like this. And there is a node separate here in the middle, and in the bottom we have two connected nodes. So this is the graph. Since there are three disconnected components, there might be disconnected components like you can see in this graph. This is a single graph where there are three components and those three components are disconnected. So now what we can do, like the pretty simple approach to solve this problem would be like we can go through every component, and we can do a traversal algorithm like BFS to visit all the nodes, and like for each component we will just visit all the nodes and make it will take a counter. We take a counter from 0. If we visit all the nodes in a component, we'll increase our counter plus plus. This is for counter plus plus. This is for counter plus plus. So this is a pretty straightforward approach. So like we can use depth first search as well. Like there is another concept called disjoint set data structure. We can use disjoint set to solve this problem as well. But for this video, we will just go through the breadth first search algorithm. If we see the breadth first search, you can pretty much do the DFS by yourself. So, this is our simple approach. We have a counter starting from 0, and we will check for all components. We will just call our BFS function, and we will have a counter plus plus. Finally, we'll return our count. So the main game is in the BFS function. So our BFS function will have multiple parameters. First, it will have an x index and it will have an y index since this is a matrix. And we have a visited array and our matrix itself. Matrix, suppose. Yeah. So for any standard BFS algorithm, we need to have a data structure queue. If you know BFS, you can pretty much compare. So since this is a matrix, we need to store the row index and column index, we need to store both. So this will be a queue of pair of int comma int. Okay. Then we will push the indexes that we are passing into the function. So x comma y, we will push and we'll mark it as visited of x comma y should be true. Now the main game comes here. So then we will iterate over the queue while our queue is not empty. While our queue is not empty, what do we need to do here? We will extract the indexes, x index and y index, and we will for that particular node we will check the adjacency list of that, or we can or you can say we'll go over the child nodes of that node. So uh, so suppose our row value should be q dot front dot first, since we are passing the x value at the beginning, and our column value would be q dot front dot second. Then we'll pop our queue. If you are using Java, you can do this in a single operation. You- But I'm doing in C++. Now, now we need to check the adjacent nodes of this node, of this row column. We so what we can do is we can do a trick over here. Suppose I have a node here. The value is x comma y. The index is x comma y. So the four directions that we can move through is up, down, left, and right. So if we move to right, so the index of the node would be x plus 1 comma y. If we move to down, the index node will be x comma y minus 1. If we go upwards, it would be x comma y plus 1. If we move to our left, it would be x minus 1 comma y. So we can keep a track of a order. Suppose we are going cyclic way, or you can say clockwise. So we start from here, then we'll go here, then we'll check this node, then we'll check this node, this position, sorry. Yeah. So we will have a dx, suppose we have a dx array where we will store the changes of in terms of index. So for upwards, there is no change. So x should be 0. For the right position, there is a plus 1 change. So we'll write 1 here. For downwards, there is no change. We write 0 here. For left, there is minus 1. Similar goes our dy array. Um, for upwards, there is plus 1 change. For down right, there is no change. For downwards, there is minus 1. For left, there is no change. So now what we can do, we can go through a for loop for I equal to 1 to 4, and we will find our new nodes. So our n row should be um, row plus dx of I. This will traverse all the nodes sequentially. Same goes for ncol. Our new column would be column plus dy of I. See, now our adjacent nodes are checked. We have our adjacent nodes, all our adjacent nodes. Now we need to check these n row comma n row comma n call node is in the matrix itself. This node is in the matrix itself. So let's see if we have a function if is possible of n row comma, so this will be n row comma n column. If it is in the matrix, then we will just mark it as visited of n row comma n call should be 1, and we will push it into our queue dot push n row comma n call. So this is a straightforward BFS function. This is how our BFS function will look like. So now this will traverse all the child nodes of that node, and i- if for a single component the traversal is complete, then it will move to a second component, and the counter will increase, and to the third component, then the counter will again increase, and finally it will return the answer. So let's move on to the coding, and it will be even more clear then. Okay, so what do you need to have here? We need to have a vector of vector, let's say bull. This will be our visited matrix, and we need to have the size. So int n should be grid dot size, and intm should be the column size, grid of 0 dot size. Okay, so the visited array should be of size n cross m, vector and sorry, this should be bool, vector bool of m. Okay, okay. Now, now we will go through the components. So for going through the components, what we can do is we can we can do one thing, like we can have a nested loop for int I equal to 0, I will n. We'll see if our visited of ij is not 0. If it is visited already, we don't need to call our BFS function. So suppose for you can see here, if we for a component we have already called the BFS function, the all the ones will be marked as visited. So we don't need to go through all the ones. This will mark it as visited for the first BFS call. The second BFS call will mark this one as visited. Then it will move to this one and this one. So it will work like this. And we need to check is our grade of ij, is it 1? We need to check it as a 1. So if it is a 0, we don't need to call our BFS function, because 0 means water. We don't need to iterate over zeros. So now what we'll do, we will just call our BFS function. We'll call our BFS function. It will the parameter should be ij. Okay, should be semicolon, visited matrix and our grid. We'll have a count plus plus, this should be above. We need to have a variable counter, and the count should be 0. Then we will return our count. Okay, now we can write our BFS function. Void BFS, it accepts parameters int I, int j, vector of vector pull visited. This should be passed by reference. Remember to pass it by reference. And what is happening with my keyboard? vector of vector character, and this should be our grid. Okay, now what do we have? We need to have a queue of pair of and comma and queue. We'll push q dot push I comma j. Let's mark it as visited. Set of ij should be 1, or we can say true. Then we will iterate over the queue while q dot not empty, not q dot empty, like that. And we will have our row, and the row should be q dot front dot first, and the column should be q dot front dot second. Now we need to have a dx and dy array, as I have already told. Vector and let's call it as d row. D row should be equal to, okay, I need to check vector and d call. Okay, so it was 0 1 0 minus 1 for x, 0 1 0 minus 1, and for column this was 1 0 minus 1 0, 1 0 minus 1 and 0. Now we will check its adjacent rows. Anti I equal to 0, I less than 4, I plus plus. We can take it as I. Since I have already taken I over the function, we can do is make it as k. Okay. So our new row should be row plus d row of I. Same goes for our column. This should be column. New column should be column plus d column of I. Now, if it's possible of n row comma n col. We have passed this, and we need the size of the matrix as well. So int n should be grid dot size, int m should be grid of 0 dot size. So n comma m. If it is possible, we will mark it as visited of n row n col is true, and we will push into our queue. N row n col. Right. Now we need to check we need to make our is possible function as well. Bool is possible should be int I comma j, int j. This is our row and column value, and we have the size of the rows and columns. So n m. Okay, it should be m. Yeah. So if our I is less than, I should be greater than equal to 0, and I should be less than n, and n. J should be greater than equal to 0, and j should be less than m, And we also need to check if it is already visited or not. So visited of ij should also not be visited, right? And we also need to check if it is a land or a water. So we need to have the grid as well. Grid of I j should be double equal to 1. Oh my god, what is happening? Yeah, if it is, then we'll return true. Otherwise, we'll return false. Right. So we need to have the uh, visited matrix here and vector of vector character grid. Right. I think it's done, and we will pass the visited and grid here as well. So I think it's pretty much done. This code looks fine. Let's run it. Did give some result. Okay, okay. I have made some is possible is declared here. Okay, okay. And there's a typo. There should be a B. Okay. Okay. I forgot to pop the Q here. So we need to pop, otherwise it will give a TLE. Now let's run it. I think it's done. Yeah, it's accepted. Let's submit it. Yeah, it's accepted. So, thank you everyone for watching.